All right, so buckle up because today we are diving deep into a whole stack of reports and articles all about the recent shakeup at Intel.
Yeah, this is gonna be a good one.
You probably at least heard about the CEO change.
Definitely a big one.
But we're going way beyond just the headlines here, right? We're trying to figure out what this whole thing tells us about the global landscape of making computer chips.
Like where are the chips coming from? Who's making them? Where are they going? All that.
And the big, really big question we're going to try to tackle today. Can the U.S. actually achieve self-sufficiency when it comes to these chips? Like, can we make all the chips we need right here?
And it's a lot more complicated than people probably think.
Yeah, it is. So let's start with the news that kind of kicked all this off. Pat Gelsinger, Intel's CEO, he's out.
Yeah, he's gone.
And this is not just any CEO. Like this guy, Gelsinger, he's a longtime Intel guy.
Intel lifer.
Served as CTO even before he came back to be CEO in 2021.
His return was a big deal.
Huge deal. Like people thought he was going to be the one to turn things around for Intel.
Almost like a prodigal son, right? Coming home to save the day.
Totally. And Gelsinger, he had this vision of like bringing chip manufacturing dominance back to the U.S.
Back to American soil.
And he really put Intel's money where his mouth was, investing tons of cash into building new factories, expanding old ones, all here in the U.S.
Putting those plants right here.
And he had some serious government support for that too, right?
Oh yeah, for sure. The Cheap Potatoes Act of 2022, that was all about giving a boost to chip production, specifically here in the U.S.
It was like a big push from both the government and from inside Intel to bring chip making back home.
Bring those jobs back, bring that expertise back.
But then, fast forward just 3 years, and Gelsinger's out.
Gone.
Intel stock's taking a hit. They're having to make some serious cuts.
Not looking so good.
So the question is, what happened? Like, why is this grand plan not working out the way everyone hoped it would?
$1 million question.
Before we dive into what Intel might have done wrong, though, I think we need to understand why the U.S. government is so invested in this whole semiconductor thing in the first place.
Yeah, why do they care so much?
I mean, what makes chips so important? What makes them so vital that we're willing to pour billions of dollars into bringing their production back to the U.S.?
It's way bigger than just your laptop or your phone, right? We're
Yeah.
talking about basically the brains behind all modern technology.
Chips are everywhere.
Everywhere. And for the government, a big part of it is national security. Like, straight up, these are the chips that are powering hypersonic missiles, AI-powered defense systems, all that cutting-edge military tech.
So chips equal national security.
In a big way.
Okay, that makes sense. But then if Intel was supposed to be the one leading this charge, bringing production back to the U.S., why are they the ones struggling?
Yeah, why can't they get it together?
To understand that, you got to look at Intel's history, how they went from being like the king of Silicon Valley to, well, not the king.
Fall from grace.
They were so focused on what they knew, making these super powerful but expensive CPUs for PCs and servers,
The workhorses of the computer world.
that they kind of missed the boat when the mobile revolution hit.
Yeah, they were a little late to that party.
So everyone was getting excited about smartphones, tablets, all that. And Intel was still betting big on, like, the desktop computer.
Kind of. They didn't really jump into developing their own mobile chips. And there were people, even back then, telling them, hey, you should get into the business of making chips for other companies, like TSMC does.
But they didn't listen.
Nope. Stuck
Yeah.
to their guns, and it cost them.
How so?
Well, for one thing, it cost them a ton of money. They didn't have the cash to invest in the next generation of chip-making tech because they were so focused on their existing stuff.
They were making good money with what they had, so why rock the boat, right?
Right. Exactly. And that's a classic example of how this focus on short-term profits, keeping Wall Street happy, can actually stifle innovation.
It's like you're so worried about making money today that you forget to invest in the future.
Exactly. Even a company as big as Intel, they can get caught in that trap.
So while Intel was focused on what was working right now, another player was emerging with a totally different strategy. TSMC.
The Taiwan Semiconductor Manufacturing Company.
Yeah, that one. I hear that name all the time, but I got to be honest, I don't really get what they do differently.
Oh, they do things very differently. For starters, they focused on making tons and tons of chips for mobile devices.
Smartphones, tablets, that kind of thing.
That's it. It might not have been as profitable per chip, especially in the short term, but it gave them the resources to invest early in some really advanced chip-making technology.
What kind of technology?
Stuff like extreme ultraviolet lithography. It's called EUV for short.
EUV. Sounds complicated.
It is. Basically, it's a super precise, super high-tech way of creating the ridiculously tiny patterns on chips.
The stuff you need for the most advanced processors.
Exactly. And because TSMC got in early on this, they got a huge head start.
So they were playing the long game, while Intel was focused on the here now.
Exactly. But it wasn't just about the tech itself. TSMC, they built this whole ecosystem around chip making.
What do you mean by that?
They made it super easy for other companies to design and order chips from them.
Like they were super customer friendly.
Exactly. They have this 24/7 online platform where companies can actually work directly with TSMC engineers on their chip designs.
That's pretty cool.
It's incredibly efficient, incredibly streamlined, and that, combined with their early investment in all that fancy technology, allowed them to pull ahead of everyone.
Including giants like Samsung.
Oh yeah, Samsung and, of course, Intel.
So Intel sees all this happening, sees TSMC pulling ahead, and realizes they got to change course.
Time for a new flan.
And that's where Pat Gelsinger comes back in, right? He comes back to Intel with this big vision. We're going to bring chip making back to the U.S. And part of that was Intel Foundry Services, IFS.
Right, IFS. Basically, Intel trying to do what TSMC does.
Make chips for other companies.
Exactly. Gelsinger, he saw that Intel needed to get into that business, not just design their own chips.
So it was a big bet, going head-to-head with TSMC.
A huge gamble.
And, well, we already know it didn't work out.
Not quite.
Why not?
That's where Intel's history comes back to bite them. They had this very, how should I put it, ingrained bureaucracy.
Like they were stuck in their ways.
Exactly. This risk-averse mentality, very slow-moving, and that just doesn't fly in the world of chip making.
Where things are constantly changing.
All the time. You got to be fast, you got to be nimble.
And Intel just wasn't.
It's hard to change a company that big that's set in its ways. And we see this really clearly with what happened with Likutan.
He was brought onto Intel's board specifically because of his expertise in semiconductors, right?
Oh, yeah, he was the guy. Tons of experience, especially in the foundry business, making chips for other companies.
Exactly. Like, they brought him in specifically to help with this whole IFS thing.
He was supposed to be the secret weapon.
But he ended up resigning.
Yeah.
Just 2 years later.
Walked right out.
Why? What made him get up?
He was very clear about it, actually. He said Intel was just too slow, too bureaucratic, too risk-averse. They just couldn't move fast enough to compete in this new world.
So even with someone like Tan on board, they just couldn't change their ways fast enough.
It seems that way. And when he left, it left a big hole on Intel's board, right when they needed that expertise the most.
So even with all the money, all the government support, turning Intel into a TSMC competitor was just too big of a challenge.
It was a massive undertaking, and it looks like it just didn't pan out. Which brings us back to that original question. Can the U.S. really achieve self-sufficiency in semiconductors? Can we really make all the chips we need right here?
It's a big question, a really big question, and one that we'll keep digging into.
Oh, yeah, we're just getting started.
All right, so we've seen that Intel's attempt to kind of, become the next TSMC didn't exactly go as planned.
It was a bold move, but yeah, it didn't quite pan out.
But it really brings up this even bigger question, right? Can the U.S. actually get to a place where we're totally self-sufficient when it comes to semiconductors?
It's the million-dollar question, and it's way more complex than just, building more factories here.
Right. It's not just about having the physical buildings.
It's the whole ecosystem, the knowledge, the people, the supply chains.
And even, the culture of innovation, right?
Yeah.
You got to have the right environment for that kind of cutting-edge tech to thrive.
Exactly. And then you've got the geopolitical stuff layered on top of all that.
Yeah, earlier we were talking about how important chips are for national security.
Vital.
But if the U.S. military is relying so heavily on chips made by TSMC over in Taiwan,
Which they are.
doesn't that create a huge vulnerability, especially with all the tension with China?
Oh, absolutely. The chip shortage a couple of years ago, that was a wake-up call.
Big time.
Imagine, things escalate around Taiwan. Suddenly, those chips, the most advanced chips in the world, they're cut off.
And that would have a ripple effect across the entire global economy.
Everything would grind to a halt.
Not to mention, the impact on U.S. military capabilities.
That's the real nightmare scenario.
So it sounds like relying only on domestic production, even if we could get there, might not be the answer.
It's too risky, putting all your eggs in one basket.
So where does that leave the U.S.? What are the options?
Well, one approach is diversifying the supply chain.
So not just relying on one company or one country.
Exactly. Spread the risk around a little bit, partner up with other big players.
Like who?
Well, you've got Samsung in South Korea. They're a powerhouse.
Right, Samsung.
And maybe even exploring some collaborations with Japan, the European Union.
So build relationships with multiple suppliers.
Multiple sources, multiple partners.
Okay, that makes sense.
Or-
But even if we diversify, wouldn't the U.S. still be kind of dependent on other countries for those, like, top-of-the-line, most advanced chips?
Yeah, that's a real possibility. TSMC, they hold a unique advantage right now.
They're just that good.
They're that good. They've poured a ton of resources into their fabrication capabilities, and their expertise is unmatched.
So even companies like Tesla, who design their own chips for their cars and stuff.
Tesla, they're designing some really impressive chips, but guess where they get them manufactured?
TSMC.
You got it. TSMC's foundries in Taiwan. Even the companies designing their own chips are still reliant on them.
So diversifying is important, but it doesn't totally solve the problem.
It's a piece of the puzzle.
What else can the U.S. do to, like, strengthen our position in all this?
Well, on top of diversifying, we got to focus on nurturing our own talent here.
Growing our own chip experts.
Exactly. This industry, it needs highly specialized knowledge, skills that take years to develop.
You can't just, like, train someone up in a few weeks.
No way. We need to invest in education, training programs, apprenticeships, all that, to create the next generation of chip designers and engineers.
So it's not just about the factories, it's about the people who run them, the people who design the chips.
It's the brains behind the operation, and that's something the U.S. has always been good at, attracting the best and brightest from all over the world.
We've got the universities, the research labs.
And we need to leverage that, make it a place where those brilliant minds want to come and work on this stuff.
That's a good point, but attracting talent is one thing, keeping them here is another.
Especially when you've got companies like TSMC offering, competitive salaries, state-of-the-art
They're
facilities.
pulling out all the stops.
They are. So we need to create an environment here where people want to stay and build their careers.
And that means more than just good jobs, right?
Right. It's about the whole package. Immigration policies, making it easier for people to come here and stay here illegally.
Making it a welcoming place.
Exactly. And investing in research and development, giving these brilliant minds the resources and opportunities they need to do their best work.
So it's like, we're not just competing with companies like TSMC on a technological level, we're competing on a cultural level, too.
Absolutely. We need to recapture that spirit of innovation, that drive to push the boundaries that we used to be known for.
Which brings us back to something we talked about earlier. Wall Street's focus on short-term profits.
That's the elephant in the room.
How do we encourage companies to take risks, to invest in these long-term ambitious projects when the pressure is always on to deliver those quarterly earnings?
It's tough. Maybe it's about shifting the incentives somehow, rewarding companies that are truly pushing the envelope.
Like tax breaks for companies investing in research and development.
Something like that. Or even just public recognition. Celebrate the companies that are taking the long view, the ones that are really trying to make a difference.
It's almost like we need a cultural shift, right? Like,
Yeah.
move away from this make money now mentality towards something more like, how can we create something truly groundbreaking that will benefit everyone in the long run?
That's it. And that's not just about government policy. It's about changing the whole conversation, promoting a culture that values long-term thinking, celebrates scientific breakthroughs, and recognizes that progress often involves taking risks and sometimes even failing.
It's a big challenge, and it goes way beyond just the semiconductor industry.
It's a fundamental question about how we approach progress as a society.
It really makes you think, what role can individuals or even individual companies play in all this? Like, how do we push for this kind of cultural shift?
That's a deep question, and one that we could probably spend a whole nother deep dive exploring.
Maybe we will. But for now, let's bring it back to semiconductors and this question of U.S. self-sufficiency. We've talked about diversifying, nurturing domestic talent, but is there a way for the U.S. to actually, like, win this chip-making race?
Win might be the wrong way to think about it.
Okay, so is it even possible to get to a place where we're not at least somewhat reliant on other countries for our chip supply?
That's the question, isn't it? But maybe an even more fundamental question is total self-sufficiency even the right goal? Maybe a more realistic and ultimately more beneficial approach is to focus on building strong, reliable partnerships with other key players in the global semiconductor landscape.
So instead of trying to go it alone, it's more about, like, recognizing that this whole chip-making ecosystem is inherently global
It is. It's interconnected.
and finding ways to work together effectively within that system.
Exactly. It's like a complex dance where everyone has their own strengths, their own unique
I
contributions.
like that analogy.
And by working together, you can create something much more beautiful, much more resilient than any one partner could achieve on their own.
So instead of trying to dominate the chip-making world, maybe it's more about becoming the best possible dance partner.
Exactly. That means building trust, sharing knowledge, investing in relationships that benefit everyone involved.
Okay, so if we shift our thinking away from this idea of complete self-sufficiency and move towards building these strategic partnerships, what would that look like in practice? Like, who should the U.S. be partnering with?
Well, we've already mentioned a few key players: Taiwan, South Korea, Japan, the European Union.
All places with strong semiconductor industries.
Exactly. They've got the expertise, the infrastructure.
But those are also places with their own geopolitical interests, their own ambitions. How can the U.S. make sure that these partnerships are actually mutually beneficial, that we're not just creating new dependencies?
That's the balancing act, right? The U.S. needs to be assertive in protecting its interests, but also open to collaboration.
That's like walking a tightrope.
It is. But it's a tightrope we got to learn to walk if we want to stay ahead in this global technology race.
And speaking of staying ahead, it's not just about semiconductors, right? It's about the whole innovation ecosystem.
Right, we got to think bigger picture here.
What do you mean?
Think about the areas where the U.S. still has a clear lead: software development, artificial intelligence, cloud computing.
All the stuff Silicon Valley is known for.
Exactly. And all of those things, they're deeply intertwined with semiconductors.
They need those chips to function.
They do. So by leveraging our strengths in those areas, we can create this powerful synergy that drives innovation across the board.
So it's like a positive feedback loop. Advancements in AI and software lead to more demand for advanced chips, which then fuels more innovation in chip making.
Exactly. It's about creating an ecosystem where all these different technologies and industries feed off each other, push each other forward.
Okay, so it sounds like maybe achieving semiconductor self-sufficiency is the wrong goal. Maybe it's more about striking a balance between domestic production and these strategic global partnerships, all while nurturing this robust innovation ecosystem.
That's the recipe for success.
It's complex, it's multifaceted, there's no easy answer.
Which is why we're talking about it. These are the issues that are going to shape the future, not just of technology, but of the world.
And speaking of shaping the future, I think it's time we brought all this back down to earth a little bit.
Back to reality.
Because all this talk about semiconductors and geopolitics, it can feel kind of abstract, you know?
Head in the clouds.
Exactly. So let's talk about what all this means for the average person, the person listening to this right now.
Let's bring it home.
What does the future of chip making have to do with their life, with their wallet?
That's the question, isn't it? And it's one we'll be exploring in the final part of our deep dive.
We're going to get into the nitty-gritty of how all this impacts you.
Everything from the cost of your next smartphone to the future of artificial intelligence.
So don't go anywhere. All right, so welcome back for the final part of our deep dive into the world of semiconductors. We've talked about Intel, we've talked about national security, but now it's time to get down to brass tacks. What does all this mean for you, the listener?
It's easy to get caught up in the big picture stuff, geopolitics, global supply chains. But at the end of the day, semiconductors touch every single part of our lives.
Yeah, because let's be real, when most people hear semiconductors, they're probably thinking, okay, cool, but what's that got to do with me?
Well, here's the thing. They're the invisible force behind pretty much all the technology we use every single day.
They're everywhere.
They are. Smartphones, laptops, cars, smart homes, you name it, it's got semiconductors in it.
It's like they're the tiny little engines powering the modern world, even though most of us never even see them.
Perfect analogy. And these chips, they're only getting more advanced, which means they're going to have an even bigger impact on our lives, like on everything: healthcare, transportation, entertainment, you name it.
Everything.
Everything. Take artificial intelligence, for example. AI, it needs a lot of computing power to process all that data, and that power comes from chips.
So as chips get better, AI gets better.
Exactly. Which means we're going to see AI integrated into more and more things.
So like self-driving cars becoming more common.
Oh, yeah, for sure. And personalized medicine, our home's getting even smarter.
Like sci-fi stuff becoming reality.
It's already happening. And it's not just about cool gadgets either. These advancements, they could have a huge impact on how we tackle big global problems like climate change, disease.
Okay, that's the exciting stuff. But what about the potential downsides?
What do you think? Are?
Well, like we hear a lot about AI taking over jobs, robots replacing humans. Is that something we should actually be worried about?
It's a valid concern, for sure. Some jobs are definitely going to be impacted. No way around that.
But isn't it also possible that new jobs will be created, like
Yeah.
jobs we can't even imagine yet, in fields related to AI, chip design, all that stuff?
Absolutely. That's always been the case with technological revolutions, right? New tech, new jobs.
Right.
The key is adaptability, being willing to learn new skills, roll with the punches. And it's not just about technical skills either. We're also going to need people who can think critically about the ethical side of all this.
Oh, interesting point.
Yeah.
So, like philosophers, ethicists, social scientists, they'll all have a role to play.
For sure. We got to make sure these powerful tools are being used responsibly, for the benefit of everyone. And that's a conversation we need to be having now, not later.
Absolutely. So we've got these amazing opportunities on the horizon, but also some serious challenges to consider. But what about the more immediate stuff? Like, how is all this going to affect the average consumer, in the next few years?
What are you worried about?
Well, like, we've been hearing about this chip shortage. Does that mean our next phone or laptop is going to cost an arm and a leg?
The shortage has definitely had an impact on prices, no doubt about it. But it's also kind of forced companies to get creative. Like they're finding new ways to optimize how they use chips, which could actually lead to more affordable devices down the road.
So every cloud has a silver lining.
You could say that. And for consumers, I think the most important thing is to stay informed, understand what these chips are, why they're important, and be aware of all the global stuff going on. And then, make informed choices about the tech you buy and use.
So listening to podcasts like this one, that's a good start.
Absolutely. The more we know about the tech that shapes our world, the better prepared we'll be for whatever comes next.
Couldn't agree more. So as we wrap up this deep dive, is there one key takeaway you want listeners to walk away with?
I think it's this. The future of chip making, it's not just about technology, it's about the future of humanity.
It's that big.
It is. It's about what kind of world we want to build. A world with amazing possibilities, sure, but also a world that demands careful thought, ethical awareness, and a commitment to using these powerful technologies for good.
Really well said. So, listeners, as you go about your day, think about the chips in your devices, the global forces that brought them to you, and the impact they have on your life. And think about the role you want to play in shaping the future of technology.
That's what it's all about.
Thanks for joining us on this deep dive. It's been a fascinating conversation.
My pleasure. Always a good time.